Hello. In this video, we will be going over how to classify numbers. There's two main ways to group numbers, so we'll start with these real quick. Positive numbers are any numbers that are greater than 0. So if somebody asks you for the solutions that are greater than 0, you know they're talking about the positive solutions. Conversely, with negative, it's anything less than 0. So if they ask for any solutions that are less than 0, you know they're talking about negative solutions. And 0 just equals 0. There's one thing there. Moving on to our second categorization, we have integers. Integers are also known as whole numbers, and they're any value that does not have a fractional value. So, doesn't matter if it's negative or positive or 0. It's anything that doesn't have anything after the decimal other than 0. So moving on into rational numbers. Rational numbers include integers, but can also be anything that has a decimal value that can be written concisely or rationally. For example, 1/2, we know that 1/2 can be expressed as 1/2. We also know that it can be expressed as 0.5. This number right here, negative 2.81 repeating, while it might not be a pretty number, we know that we can rationally state that it is negative 2.818181818181 going forever. We know how to state that. And, like I said, all integers belong here, positive or negative. Now, to move on to the irrational numbers are anything that doesn't fit in the rational numbers category. For example, this value right here, we have no idea how it's going to continue. When written down, we have to lose some accuracy. We can put a 3, 4, 5, 8, 9, 2, 3, 8, 7, 6, 5. There's no pattern that we know, and it also doesn't fit in a fractional format, so we can't write it rationally. Same with the square root of 3. We know what it is. We can write it down to a certain extent, but then we have to start dotting. Or we can write it as the square root of 3, which isn't a rational expression because it has to take into account the root. It isn't in its fully reduced form. Same with pi. Pi just keeps repeating forever in some large pattern that we can't just grasp. But if we combine our rational and irrational numbers, we get real numbers. Any number that can be written down that doesn't require one of these guys is a real number. The reason that it's known as a real number is because it sits on the opposite side of the fence as imaginary numbers, which do need an I. And if you haven't gotten to the point where you've used an I in math yet, the reason that an I is here is that I is equal to the square root of negative 1. And if you're familiar with taking the square root, or the even root of a number, rather, you know that it can't be done. Because nothing squared, there's no number that you can square and get negative 1. So I is used as a placeholder when we've done math where we wind up with the square root of negative 1 somewhere. We use it in order to express that we understand that this is equal to the square root of negative 1. So we can also say that right here, this guy, just the I, is square root of negative 1. This 3 plus 2i is 3 plus 2 times the square root of negative 1. And 5i is 5 times the value square root of negative 1. So there you have it. That's how to classify your numbers. If somebody asks for integer solutions, they must be whole numbers. In other words, they don't have any decimal values. If they want a positive or negative, you know how to look for that now. Rational numbers, you know how to write things in a rational form. Irrational numbers, you know that they won't be writable in a rational form. Real numbers, you know that they include every number except for imaginary numbers. And imaginary numbers just kind of exist on their own over here. If you have any questions, please feel free to leave them in the comments and I will answer as soon as I can. And thank you for watching.